Hello and welcome back to MechZone. We have already started with the subject of engineering mechanics, and in the first lecture we have already studied about the forces, and in forces we studied about the different systems of forces, what is a rigid body, how we are going to resolve the forces into its components along the x-axis and along the y-axis, what are coplanar forces, what are concurrent forces. We have already studied that. Now before starting this lecture, I would simply like to request you, if you have not subscribed to our channel yet, kindly do so by hitting the subscription button and also press the bell icon so that all the important updates are received by you at the earliest time. So let us start with this topic, that is the second lecture, and it is all about the free body diagram, Lami's theorem and types of equilibrium. Now Lami's theorem is an important theorem because you can get questions from this topic in GATE if they are asked. Then it can be solved by the Lami's theorem. However, there are many other methods to solve a question, not exactly just by Lami's theorem. And free body diagram is an important topic because in order to visualize the body equilibrium, we have to draw the free body diagram, and by drawing the free body diagram we'll be making sure that all the forces are acting on the body, and then we are going to study about those forces. So let us start with the first thing, that is what is a free body diagram. So in physics, when we were doing in class 11th and 12th, we have already drawn the free body diagrams of the body such that we were isolating the body, मतलब उस body को हम लोगों ने isolate करके separately draw किया और उस पे सारे लगने वाले forces को हम लोगों ने draw किया था. Weight is always acting in the vertically downward direction, और अगर कोई भी externally applied force होता है तो उसको particular direction से हम लोग represent कर सकते हैं, और the bodies are generally represented by dots or by a point masses. ठीक है. So the various forces which are acting on the body कौन कौन से हो गए? Normal reactions, as I have already told you. देखिए forces जो होते हैं they are of mainly two types, contact forces and the non-contact forces. So in case of the contact forces, there should be a physical contact between the agent which is applying the force and the body on which the force is applied. And non-contact forces like magnetic force, gravitational force, here the physical contact is not there between the agent and the body on which the force is applied. However, weight can be considered both as a contact as well as a non-contact force, because contact में जब आप रहेंगे ground के तो लगेगा ही लगेगा, और अगर आप body किसी तरीके से elevate कर दिया, मान लीजिए हवा में हम उड़ रहे हैं तो भी हमारा वेट तो लगेगा ही. ठीक है. तो ये बोथ हमारा कॉन्टैक्ट फोर्स एज वेल एज नॉन कॉन्टैक्ट फोर्स दोनों ही की कैटेगरी में हम कंसिडर कर सकते हैं. Then we have the self weight, reactions, friction and tension are also some of the forces which are also shown in the free body diagram. So we have a question, and we have been given that a sphere is suspended from a wall by means of a string, and the weight of the sphere is 100 Newton. So this is actually a sphere, this is a vertical wall such that the sphere is being hung from this wall making an angle of 20 degree. And the string is making an angle 20 degree with the vertical as shown. We have to find out the tension and the reaction of the wall. Now definitely at this point of contact, the sphere and the wall, at this point we are going to have a reaction by the wall, and due to the weight there will be some tension which will be developed in this sphere, which will be developed in this string. Now let us draw the free body diagram. That means first let us discuss what are the forces which will be acting in this case. We have one tension force, then we have the weight of the sphere acting vertically downward, then we have one reaction force. So this is actually the diagram of the sphere, that is this angle is also going to be 20 degree, that is simply by symmetry you can analyze. And if we draw a line here, then we are forming a Z. Okay, we are forming a Z, and the interior opposite angles are 20 and 20. So this is the normal reaction by the wall. This is 20 degree, this is the tension, and this is mg, that is the weight. Mg has been given as 100 Newton. Now we will resolve these forces into the vertical and the horizontal component such that T cos 20 and T sin 20 will be along this direction. So T cos 20 would be equals to mg, and T sin 20 would be equals to n. So T cos 20 and T sin 20, it can be very easily solved, and T is coming out to be 106.42 Newtons. And if we have to find out n, then we will keep T sin 20. Okay, sin 20 and cos 20 can be simply evaluated from the virtual calculator. You can evaluate this, and we will keep the values and we will get the answer, and normal reaction is coming out to be 36.39 Newton. So this is a very simple question which is based upon the free body diagram concept. That means we have to isolate this sphere and we have to represent all the forces which are acting externally on this sphere. Okay, so this was the very simple numerical which was also asked in one of the examinations, where we simply have to resolve the forces along the vertical and the horizontal components, and taking the summation of forces along the x-axis and the summation of forces along the y-axis to be 0, the simple equations will be formed. Now since there are two unknowns, that is t and n, so number of unknowns should be equal to the number of equations, okay, in order to have the determination of these unknowns. So we have two equations and we have two unknowns, and hence these unknowns can be simply evaluated. Now let us come to the important topic, that is the Lami's theorem. And the Lami's theorem is actually given for the coplanar and concurrent forces. So it states that if three coplanar, that means they are acting in the same plane, and concurrent means if the line of action of these forces meet at a point, are acting on a body and they are keeping the body in equilibrium, then each force is proportional to the sine of the angle between the other two forces. Now for example, this force is P, this is T, and this is Q. So if we take P, then it is proportional to the sine of the angle between the other two forces. So we have P upon sine alpha, it is equals to T upon sine gamma, is equals to Q upon sine beta, and all the three forces should be directed away. So this is an important concept in engineering mechanics, and let us solve one question which is based upon this Lami's theorem. Now here we have been given a string which is 2 meters long, is connected to the two ends of the rod. See, here we have the string and this is the rod, and the weight of the rod is about 200 Newton and it is 1.5 meters long. The string passes over the smooth nail. Find the tension in the string if the rod remains horizontal. Now the rod is remaining horizontal. We know that the weight, if this is actually the free body diagram, and the free body diagram is representing the various forces, that is the weight of this rod is 200 Newton, which is acting from the center of centroid of this rod. Then we have these two strings, and sorry, this is the string which is passing through this nail, okay, and this is the tension force, that is weight is acting downward, so tension is acting away because it has to keep the string in tension. So the direction of tension would be like this, and we will resolve this tension force into two components such that one is T sine theta and the other one is T cos theta. Now the biggest problem is how to find out theta. So we know that this is entirely, this is given as 2 meter, entire string is 2 meters, so this is 1 meter, okay, and the length of the rod has been given as 1.5 meters long. So we are going to take sorry, it is not 1.5, rather it is 1.6 meters long, okay. So 1.6 meters, that means this will be 0.8 and this will be 0.8. Now let us consider this small triangle such that this side is given as 1 meter, this is given as 0.8. So we can apply, yes, cos theta is equals to base upon hypotenuse. So we can easily obtain the value of theta, and once we obtain theta, we can get the value of this length. It is coming out to be 0.6. So by taking the summation of forces along the x-axis and the summation of forces along the y-axis to be 0, we can also solve this question. But we can also apply Lami's theorem here. So this is T sine theta. See, T sine theta and T sine theta would become 2T sine theta in the upward vertical direction, and this is being balanced by the weight of this rod, that is 200 Newton. So 2T sine theta is equals to 200. So T simply becomes 100 upon sine theta. Okay, 200 मतलब 200 से 2 मतलब ये कटा तो 100 आ गया. So tension is coming out to be 166.66 Newton. So this was the question which was very simple. It was asked in one of the examinations. Now let us go for the another question, and it says that a ladder of 2.5 meter long weighing 120 Newton rests against a vertical wall and a horizontal floor which is smooth. Now we have been given that floor is smooth. It means that there is no friction between this ladder and this horizontal ground. Okay, so determine the force horizontal applied at the bottom of the ladder to prevent slipping. Now we have to evaluate the force or the horizontal force which is applied at the bottom of the ladder to prevent the slipping. Now initially this ladder is making an angle of 60 degree with the horizontal ground. Now first we will draw the free body diagram of this ladder such that from this wall, let us say that we are having a force P or a reaction NP is acting at this point, and a reaction of NQ is acting at this point, such that this is the ladder. If this is 60 degree, this is 90 degree, this would be 30 degree, and if this is 30 degree, this is also going to be 30 degree, and 60, so this is 60. This is very simple geometry of class 6, and what we will do is we will simply take summation of fx along, summation of fx is equals to 0 and summation of fy is equals to 0, and by writing it down we will obtain the equation as np into 2 sine 60. So we are actually taking what? We are taking the moments. Okay, so np into 2 sine 60. 2 is the length of this rod. Okay, 2 sine 60 minus 120 into 1 cos 60, because 120 this is acting exactly at the center, so this length is 1 and cos 60 is equals to 0, and we have to find out the reaction at P. So NP is simply coming out to be nothing but 34.64 Newton. So this is simply we are taking the moments, okay, and moment about the point Q has been taken here. Okay, तो ये हो गया हमारा NP into 2 sin 60 minus 120 into 1 cos 60 is equals to 0. So this is coming out to be 34.64 Newton. So this is nothing but we have to remember three basic equations, that is summation of forces along the x-axis is equals to 0, summation of forces along the y-axis is equals to 0, and summation of the moments about an arbitrary point is also equals to 0. So three equations needs to be remembered. Okay, now let us discuss the different types of equilibrium, and the three types of equilibrium are the stable equilibrium, unstable equilibrium and the neutral equilibrium. In the stable equilibrium, this is actually representing the state of stable equilibrium such that if this object is displaced from its mean position, then if it is displaced either towards the right or towards the left, then after the release this object is going to return to its initial position. Okay, so this is actually representing the stable equilibrium phenomena. Now for the unstable equilibrium phenomena, if this object is displaced slightly towards the left or towards the right, then it is never going to return to its initial or the mean position. So this is actually representing the case of unstable equilibrium. And for the neutral equilibrium, if it is displaced, then you can see that it will remain in the same level of state. So this is actually representing the case of neutral equilibrium. Now we come to the principle of virtual work, and the principle of virtual work simply states that if a system of forces is acting on a body or a system of bodies to be in equilibrium, and the system is imagined to go a small virtual displacement consistent with the geometrical conditions, then the algebraic sum of the virtual work done by the forces in the system is 0. And we know that work is equals to force into displacement. So if there is any virtual displacement, then the work associated with that would be simply 0. The summation of the virtual works done by the forces in the system would be simply 0. This is all about the principle of virtual work. So with this we come to the end of this lecture. I hope that you have enjoyed this lecture, and kindly give us your valuable feedbacks on our YouTube channel or on our Facebook page. You can also rate our Facebook page. You can go there and rate us. And you can also share your experiences with us, how you are going to, or how MechZone is helping you to achieve your target, or how you are feeling after studying from MechZone. So thank you so much, and in the next lecture we shall be starting with the third lecture of engineering mechanics.